students. This is one more session where we are going to take up few more examples on finding the rank of a matrix by reducing it to normal form. So we already know what is the definition of normal form of a matrix. How do we reduce the given matrix to normal form? If you can reduce the given matrix to any one of these four forms, if you can reduce it to any one of these four forms, then we can say that the matrix is in normal form, and where this IR is nothing but the unit matrix or the identity matrix of order R. So if you can convert the given matrix to any one of these four forms, then you say that the matrix is in normal form. And then if whatever the unit matrix you have got, the order of that unit matrix is called as the rank of the matrix, denoted by rho of A is equal to R. This is only to just recall the definition of normal form of a matrix, so that we can just continue with the examples. With the help of the definition of normal form of the matrix and how to find the rank of the matrix using the definition of normal form, let us take a few examples. And the example here we have is a matrix which is 1, 2, 3, 2, 4, 6 and 4, 8, 12. We have to reduce this to normal form and hence find the rank. Let us see how we can do this. Let us call the given matrix as A. So first step is let A equal to. Okay. Then let us write the solution. Okay. What are the operations that we need to perform? Normal form irbeku andre diagonal elements 1 agbeku, uldire ella elements 0 agbeku. Diagonal elements alli first element nodona, illa already 1 ide. So en madbeku, idralli ee elements ella 0 agbeku ಮತ್ತೆ ಈ ರೋ ನಲ್ಲಿರೋ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲ 0 ಆಗಬೇಕು. ಇದೇ ರೀತಿಯಲ್ಲಿ ಎಲ್ಲ ಪ್ರತಿ ರೋಗೂ ಪ್ರತಿ ಕಾಲಮ್ ಅಲ್ಲೂ ಡಯಾಗ್ನಲ್ ಎಂಟ್ರಿ ಬಿಟ್ಟರೆ ಉಳಿದಿರೋದು ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲ 0 ಮಾಡ್ತಾ ಹೋಗಬೇಕು. ಫಸ್ಟ್ ರೋ ಆಪರೇಷನ್ ಮಾಡೋಣ. R2 is R2 minus 2 R1 and R3 is R3 minus 4 R1. Okay, the equivalent matrix that we are going to get is first row ಏನು ಚೇಂಜ್ ಮಾಡ್ತಾ ಇಲ್ಲ, 1 2 3 ಹಾಗೆ ಇರುತ್ತೆ. ಸೆಕೆಂಡ್ ರೋ ಮತ್ತೆ ಥರ್ಡ್ ರೋ ಜೊತೆಗೆ we are making some operations, so obviously those elements will change. ಸೆಕೆಂಡ್ ರೋದು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಸೆಕೆಂಡ್ ರೋ ಎಲಿಮೆಂಟ್ ಜೊತೆಗೆ ಫಸ್ಟ್ ರೋ ಎಲಿಮೆಂಟ್ ನ -2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಅದನ್ನ ಆಡ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್ಗೆ. 2, therefore what happens is 2 minus 2 into 1, 2 minus 2 is 0. Then 4 minus 2 into 2, 4 minus 4 is 0. Then 6 minus 2 into 3, 6 minus 6 is 0. So now come to third row. Third row ಜೊತೆಗೆ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಫಸ್ಟ್ ರೋ ಎಲಿಮೆಂಟ್ಸ್ಗೆ -4 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಆಮೇಲೆ ಅದನ್ನು ಥರ್ಡ್ ರೋ ಎಲಿಮೆಂಟ್ಸ್ ಜೊತೆಗೆ ಆಡ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಏನಾಗುತ್ತೆ, 4 minus 4 into 1, 4 minus 4 is 0. 8 minus 4 into 2, 8 minus 8 is 0. Then 12 minus 4 into 3, 12 minus 12 is 0. ಈಗೇನಾಯಿತು, ಈ ಕಾಲಮ್ ಅಲ್ಲಿರೋ ಫಸ್ಟ್ ಕಾಲಮ್ ಅಲ್ಲಿರೋ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ನ ಬಿಟ್ಟರೆ ಉಳಿದಿರೋ ಎಲಿಮೆಂಟ್ಸ್ 0 ಆಯಿತು. ಈಗ ಫಸ್ಟ್ ರೋನಲ್ಲಿ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ನ ಬಿಟ್ಟರೆ ಉಳಿದಿರೋ ಎಲಿಮೆಂಟ್ಸ್ನ 0 ಮಾಡೋಣ. What happens, what is the operations that I need to consider? This time column operations. So C2 is C2 minus 2 C1 and C3 is C3 minus 3 C1. The equivalent matrix that we get is 1 0 0. ಆಮೇಲೆ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಜೊತೆಗೆ ಆಪರೇಷನ್ ಏನಿದೆ, C2 minus 2 C1. ಫಸ್ಟ್ ಕಾಲಮ್ಗೆ -2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ C2 ಎಲಿಮೆಂಟ್ ಜೊತೆಗೆ ಆ್ಯಡ್ ಮಾಡಿ ಅಂತ. 2 minus 2 into 1, 2 minus 2 is 0. 0 minus 2 into 0 is 0. 0 minus 2 into 0 is 0. ಸಿಮಿಲರ್ಲಿ ಥರ್ಡ್ ಕಾಲಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಥರ್ಡ್ ಕಾಲಮ್ ಎಲಿಮೆಂಟ್ಸ್ ಜೊತೆಗೆ ಫಸ್ಟ್ ಕಾಲಮ್ ಎಲಿಮೆಂಟ್ನ -3 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್ ಜೊತೆಗೆ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗಬೇಕು. So 3 minus 3 into 1. 3 minus 3 is 0. 0 minus 3 into 0 is 0. And then 0 minus 3 into 0 is 0. Has it been reduced? Yes, because we don't have any other operation left as second and third rows are zeros. So is it in the normal form? Yes, it is in the normal form with the identity matrix is of order 1. So nodi, this is the identity matrix. This itself is the identity matrix. All the other rows and columns are zeros. So you have an identity matrix system 1. 1 by 1. Okay, so this is of the form. Your formal ಇದೆ. In fact, ಇದು canonical form ಅಲ್ಲಿ ಇರುತ್ತೆ. IR ಅಲ್ವಾ? Identity matrix ಇದೆ, 0 columns ಇದಾವೆ, 0 rows ಕೂಡ ಇದಾವೆ. So this type ನ ಏನು ಹೇಳ್ತೀವಿ ನಾವು, ಇದು ನಾರ್ಮಲ್ ಫಾರ್ಮೇ, ಇದಕ್ಕೆ ಸ್ಪೆಷಲ್ ಆಗಿ canonical form ಅಂತ ಹೇಳ್ತೀವಿ. So this is of this form with what is R here? With R is equal to 1. Therefore, rank of A. How do you denote this? Row of A is equal to 1. So this is how you need to find the rank of the matrix by reducing it to normal form. There is one more example here. Little different one this time. We have a 0 number being seen here. Actually, ನಮಗೆ ನಾರ್ಮಲ್ ಫಾರ್ಮಿಂಗ್ ಮಾಡಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು, ಡಯಾಗ್ನಲ್ ಎಲಿಮೆಂಟ್ಸ್ 1 ಮಾಡ್ತಾ ಹೋಗಬೇಕು. ಅದು ಉಳಿದಿರೋ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ 0 ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಹೋಗಬೇಕು. ಸೊ ಡಯಾಗ್ನಲ್ ಎಲಿಮೆಂಟ್ ನನಗೆ 1 ಆಗಬೇಕು ಅಂದರೆ ಇಲ್ಲಿ ಡಯಾಗ್ನಲ್ ಎಲಿಮೆಂಟ್ ಫಸ್ಟ್ ಎಲಿಮೆಂಟೇ ಏನೋ ಕಾಣಿಸ್ತಾ ಇದೆ, 0 ಇದೆ. ಸೊ ನನಗೆ 0 ಬೇಡ, ಇಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ನಂಬರ್ ಇದ್ರೆ ಅದನ್ನು ನಾನು ಏನು ಮಾಡ್ಕೋಬೋದು, 1 ಮಾಡ್ಕೊಳ್ಬೋದು. ಹಾಗಾಗಿ ಫಸ್ಟ್ ಏನು ಮಾಡೋಣ, ಇದನ್ನು A ಅಂತ ಕರೆಯೋಣ. Okay, then what we will do is we will do one operation in such a way that I will be getting a number here which can be afterwards converted as 1. Okay, what we will do, we will write R. ನೀವು ಯಾವುದಾದ್ರೂ ಮಾಡ್ಕೋಬೋದು ನೋಡಿ, ಇವೆರಡನ್ನಾದರೂ ಚೇಂಜ್ ಮಾಡ್ಕೋಬೋದು ಅಥವಾ ಇವೆರಡನ್ನಾದರೂ ಚೇಂಜ್ ಮಾಡ್ಕೋಬೋದು. ನನಗೆ ಆಲ್ರೆಡಿ ಐ ಆಮ್ ಮೋರ್ ಫೆಮಿಲಿಯರ್ ವಿತ್ ಬಿಕಾಸ್ I already have done row reduced echelon form ಅಲ್ಲಿ ರೋ ಆಪರೇಷನ್ಸ್ ನ ಹೆಚ್ಚಿಗೆ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದದ್ರಿಂದ, ರೋ ಆಪರೇಷನ್ ಜೊತೆಗೆ ತುಂಬಾ ಫೆಮಿಲಿಯಾರಿಟಿ ಇರೋದ್ರಿಂದ ನಾನು ಇಲ್ಲಿ ರೋ ಇಂಟರ್ಚೇಂಜ್ ಮಾಡ್ತೀನಿ. ದೇರ್ ಈಸ್ ನೋ ಹಾರ್ಮ್ ಈವನ್ ಇಫ್ ಯು ಡು ದ ಕಾಲಮ್ ಆಪರೇಷನ್ಸ್, ಬಿಕಾಸ್ ನಾರ್ಮಲ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ರೋ ಆಪರೇಷನ್ಸ್ ಮತ್ತೆ ಕಾಲಮ್ ಆಪರೇಷನ್ಸ್ ಎರಡೂ ಅಲೋ ಇದೆ. ಸೊ ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನಾನು, R2 is being interchanged with R1. So the equivalent matrix is 2, 3, 5, 4, 0, 2, 3, 4, 4, 8, 13, 12. ನೋಡಿ ಇವೆರಡು ರೋಸ್ ಮಾತ್ರ ಇಂಟರ್ಚೇಂಜ್ ಆಗಿದೆ, ಉಳಿದಿರೋ ಥರ್ಡ್ ರೋಡು ಹಾಗೇನೆ ತಗೊಂಡಿದ್ದೀವಿ. ಒಂದ್ಸಲ ಈ ತರ ಬಂದ್ಮೇಲೆ ಇಲ್ಲೊಂದು ನಮಗೆ ನಂಬರ್ ಕಾಣಿಸ್ತಾ ಇದೆ. ಈ ನಂಬರ್ ಇದ್ರೆ ನನಗೆ ಅದನ್ನ 1 ಮಾಡ್ಕೊಳ್ಳೋದು ಈಸಿ, 0 ಇದ್ರೆ ಅದನ್ನ 1 ಮಾಡ್ಕೊಳ್ಳಿಕ್ ಆಗಲ್ಲ. ಹಾಗಾಗಿ ನಾನು ಇವಾಗ ಏನ್ ಮಾಡೋದು, R1 is R1 into 1 by 2. ನೀವೇನು ಮ್ಯಾಮ್ ನಾನು ಕಾಲಮ್ ಮಾಡ್ಬೋದಾ? ಎಸ್, ಯು ಕ್ಯಾನ್ ಡೂ ಕಾಲಮ್ ಆಲ್ಸೋ. ಸಿ, ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆಸ್ ದಿಸ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ದಿಸ್ ಆಪರೇಷನ್ ಕ್ಯಾನ್ ಬಿ ಈವನ್ ಟೇಕನ್ ಆಸ್, ಯು ಕ್ಯಾನ್ ಮೇಕ್ ದಿಸ್ ಆಪರೇಷನ್ ಆಸ್ C1 is C1 into 1 by 2. ನಾನು ರೋ ಮಾಡಿಬಿಟ್ಟಿದ್ದೀನಿ, ನೀವು ಬೇಕಿದ್ರೆ ಕಾಲಮ್ಗೆ ಮಾಡಿ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ ಒಂದ್ಸಲ ಅಷ್ಟೇ. ವಾಟ್ ಈಸ್ ದ ಈಕ್ವಲೆಂಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್? ದ ಈಕ್ವಲೆಂಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಈಸ್ 1, 3 by 2, 5 by 2, 4 by 2 ಅಂದರೆ 2. 4 by 2 ಅಂದರೆ ಏನು ಬರುತ್ತೆ ನಿಮಗೆ? ಎಲಿಮೆಂಟ್ 2 ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಎಲಿಮೆಂಟ್ಸು ಹಾಗೆ ಇಟ್ಕೊಳ್ಳೋಣ, ಯಾಕಂದರೆ ಒಂದೇ ಆಪರೇಷನ್ ಮಾಡ್ತಾ ಇರೋದಿಲ್ಲ ಇವಾಗಿನ. 0, 2, 3, 4, then 4, 8, 13, 12. Now I have to see to it that the elements in the first column and the elements in the first row other than this element are going to be zeros. So first ನಾನು R3 ಜೊತೆ ಮಾಡ್ಬಿಡ್ತೀನಿ. R3 is R3 minus 4 times R1. The equivalent matrix that we are going to get is 1, 3 by 2, 5 by 2 2. ಯಾಕೆ R3 ಜೊತೆಗೆ ಮಾಡ್ಕೊಂಡೆ? ಇಲ್ಲ ಆಲ್ರೆಡಿ ಒಂದು 0 ಇದೆ, ಇದು ಒಂದೊಂದು 0 ಮಾಡ್ಕೊಳ್ಳೋದು ಅಷ್ಟೇ ಕೆಲಸ ಇರುತ್ತೆ ಅದಕ್ಕೆ. ಈಗ ಫಸ್ಟ್ ರೋ ಹಾಗೆ ಇಡ್ತಾ ಇದ್ದೀವಿ, ಸೆಕೆಂಡ್ ರೋ ಜೊತೆ ಕೂಡ ಏನು ಆಪರೇಷನ್ ಇಲ್ಲ, ಥರ್ಡ್ ರೋ ಮಾತ್ರ ಚೇಂಜ್ ಆಗ್ತಿದೆ. 4 minus 4 into 1 0. 8 minus, let me do that operations here, 8 minus 4 into 3 by 2 is 8 minus 6. 8 minus 6 is 2. Okay. Similarly for the next element, let me do that here once again. So like this you can one side ಗೆ ನೀವು ಇದನ್ನೆಲ್ಲ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಫೈನಲ್ ಎಂಟ್ರಿ ಮಾತ್ರ ಈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಹಾಕ್ಬೋದು. 13 minus 4 into 5 by 2. 2 ones are 2 twos are. 13 minus 5 twos are 10. 13 minus 10 ಅಂದ್ರೆ 3. So 3 ಬರುತ್ತೆ. Okay. ಲಾಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಇದೆ, ಅದನ್ನು ಒಂದು ಮಾಡ್ಕೊಂಡ್ಬಿಡೋಣ. ಅದೇನು ಬರುತ್ತೆ? 12 minus 4 into ಆ ಎಲಿಮೆಂಟ್ 2 ಇದೆ ಅಲ್ಲಿ ಅಷ್ಟೇ. 12 minus 8 which is equal to 4. Okay, 2, 3, 4. So we have done all the operations so that the elements below the first entry of first row and first column have turned out to be zeros. So you can see these are all of them have turned out to be zeros. Now I have to convert all these elements as zeros. So what is the operation that we need to take up? We need to take up the operations that we need to take up are C2 is C2 minus 3 by 2 C1. C3 is C3 minus 5 by 2 C1. C4 is C4 minus 2 C1. The equivalent matrix that we are going to get is only first column remains the same and second column. You know that the elements only in that row will become 0. The other elements remain the same. So here you can easily write 0, 2, 2, 0, 3, 3 and 0, 4, 4. You can check this because these elements remain the same as that of the previous matrix. Now what is the operation? ಬೇಕಿದ್ರೆ ನಾವು ಇದನ್ನು 1 ಮಾಡ್ಕೊಂಡು ಆಮೇಲೆ 0 ಮಾಡ್ಕೊಳ್ಬೋದು, ಅಥವಾ ಇಲ್ಲಿ ನಮ್ಗೆ ಆಲ್ರೆಡಿ ಎರಡು ಸೇಮ್ ರೋಸ್ ಕಾಣಿಸ್ತಾ ಇರೋದ್ರಿಂದ ನಾನು ಏನು ಮಾಡ್ಕೋಬೋದು, R3 is R3 minus R2 ಅಂತ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ಬೋದು. ಈಕ್ವಲೆಂಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಏನು ಸಿಗುತ್ತೆ? 1 0 0 0 0 2 3 4 ಇದೆಲ್ಲನೂ 0 ಆಗುತ್ತೆ. Now what remains? We have to make this element as 1 and the elements in that row as 0 because already ಆ ಕಾಲಮ್ ಅಲ್ಲಿ ಏನಾಗೋಗಿದಾವೆ? 0 ಆಗೋಗಿ. What is the operation that we need to take up? R2 is R2 into 1 by 2. Or shall I do it for C2? Just see now, it becomes little easy. C2 is C2 into 1 by 2. R2 ಮಾಡ್ಬೋದು, ನಾನು ಇಲ್ಲಿ C2 ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನೋಡೋಣ. 1 0 0 0 into 1 by 2 0, 2 into 1 by 2 1, 0 into 1 by 2 0. So now 0 3 4 0 4 0. Sorry, here not 4, here you have it already as 0. We are not changing any of these third and fourth columns. What is the operation that we need to do now? Just to make these two elements 0. So how do you make this element 0? C3 is C3 minus 3 C2 and C4 is C4 minus 4 C2. So what is the equivalent matrix that we are going to get after performing this operation is, the equivalent matrix is 1 0 0 0 1 0. Then what do you have? 0 minus 3 into 0 0. 3 minus 3 into 1 0. 0 minus 3 into 0 0. Similarly 0 minus 4 into 0 0. 0 4 minus 4 into 1. 4 minus 4 is 0. 0 minus 4 into 0 0. Is it done now? Yes. We have got the matrix in the required form, which is the normal form. In fact, it is the canonical form of the given matrix. So which is in the form what is the canonical form? You have IR 0 0 0 with what is R here. What is the unit matrix that you can see? You can see that this is the unit matrix you have. And what is the order of that matrix? With R is equal to 2. The unit matrix is of order 2. Therefore, rank of A is equal to row of A is equal to 2. One more example. Let us call the given matrix as A. ಇದನ್ನ ಏನು ಮಾಡಬೇಕು? ನಾರ್ಮಲ್ ಫಾರ್ಮಿಗೆ ರೆಡ್ಯೂಸ್ ಮಾಡಬೇಕು, ರ್ಯಾಂಕ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ನಾರ್ಮಲ್ ಫಾರ್ಮಿಗೆ ರೆಡ್ಯೂಸ್ ಮಾಡುವಾಗ ಡಯಾಗ್ನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಏನಿರಬೇಕು? 1 ಇರಬೇಕು. ಆದರೆ ಇಲ್ಲಿ ಏನು ಕಾಣಿಸ್ತಾ ಇದೆ? 0 ಕಾಣಿಸ್ತಾ ಇದೆ. ಸೊ ದೇರ್ ಇಸ್ ನಥಿಂಗ್ ಟು ವರಿ. ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಡೂ ಈಸ್ ವಿ ಜಸ್ಟ್ ಹ್ಯಾವ್ ಟು ಬ್ರಿಂಗ್ 1 ಹಿಯರ್ ಬೈ ಐದರ್ ಡೂಯಿಂಗ್ ರೋ ಆಪರೇಷನ್ ಆರ್ ಕಾಲಮ್ ಆಪರೇಷನ್. ನೋಡಿ, ಈ ಕಾಲಮ್ ಅಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು 0 ಇರೋ ಎಲಿಮೆಂಟ್ನ ಬೇರೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಎಲಿಮೆಂಟ್ ಆಗಿ ತಗೊಳ್ಬಹುದು, ಅದನ್ನ ಬೇರೆ ಯಾವುದೇ ಎಲಿಮೆಂಟ್ ಜೊತೆಗೆ. ಅಥವಾ ಆ ರೋ ಅಥವಾ ಕಾಲಮ್ ಅಲ್ಲಿ 1 ಕಾಣಿಸ್ತಾ ಇದ್ರೆ ಆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ರೋ ಅಥವಾ ಕಾಲಮ್ ಜೊತೆಗೆ ನಾವು ಇಂಟರ್ಚೇಂಜ್ ಮಾಡ್ಬೋದು. ನೋಡಿ, ಇಲ್ಲಿ ನಮಗೆ ಇಲ್ಲೂ ಇದೆ 1, ಇಲ್ಲೂ ಇದೆ. ಓಕೆ, ಆಲ್ಸೋ ದೇರ್ ಈಸ್ 1 ಹಿಯರ್ 1 ಹಿಯರ್. ಸೊ ಯಾವುದಾದ್ರೂ ನಾವು ಇಂಟರ್ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಬೋದು. ನೋಡಿ, ಐದರ್ ಐ ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ದಿಸ್ ಇಂಟರ್ಚೇಂಜ್ ಆರ್ ದಿಸ್ ಇಂಟರ್ಚೇಂಜ್. ಇನ್ ಫ್ಯಾಕ್ಟ್ ಐ ಕ್ಯಾನ್ ಗೋ ಫಾರ್ R1 with R4 or C1 with C4 also. So anyhow, one operation let us take. ಅಲ್ಲಿ 1 ಬರಲಿಲ್ಲ ಅಂದರೆ ನನಗೆ, ಅಥವಾ ನಂಬರ್ ಇರಲಿಲ್ಲ ಅಂದರೆ ಅಲ್ಲಿ ನನಗೆ ಡಯಾಗ್ನಲ್ ಎಲಿಮೆಂಟ್ಸ್ 1 ಮಾಡ್ಲಿಕ್ಕೆ ತುಂಬ ಕಷ್ಟ ಆಗುತ್ತೆ, ಆಗೋದೇ ಇಲ್ಲ. ಹಾಗಾಗಿ ಅಲ್ಲಿ ನಾನು ಫಸ್ಟ್ ಆಪರೇಷನಿಂದ ಅದನ್ನ ಏನು ಮಾಡ್ಕೋಬೇಕು? ತಂದ್ಕೋಬೇಕು. ವಾಟ್ ಈಸ್ ದ ಆಪರೇಷನ್ ದಟ್ ಐ ನೀಡ್ ಟು ಡೂ? ಲೆಟ್ ಮಿ ಜಸ್ಟ್ ಡೂ R2 being interchanged with R1. Okay, so what is that we are going to get now? The equivalent matrix is, now R2 will be R1. 1 0 1 1 0 1 minus 3 1. R1 is going to be R2, R2 is going to be R1. R3 and R4 are not changed, so keep the elements as it is. 3 1 0 2 1 1 minus 2 0. So now you have element 1 here. So you see to it that the elements in that row and that, in that row and in that column, all the elements are turning out to be 0. So ಮತ್ತೆ ನಾನು ರೋ ಏನಾದರೂ ಮಾಡ್ಕೋಬೋದು, ನೀವು ಕಾಲಮ್ಮು ಅಥವಾ ರೋ ಮಾಡ್ಕೋಬೋದು. ನಾನು ಐ ಗೋ ವಿತ್ ರೋ. ಇದರಲ್ಲಿ ಈ ಆಪರೇಷನಲ್ಲಿ ಆ್ಯಕ್ಚುಲಿ ಕಾಲಮ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮ್ಗೆ ಈಸಿ, ಡೈರೆಕ್ಟಾಗಿ ಯಾವುದೇ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಇಲ್ಲಾರ್ದಂಗೆ ಮಾಡ್ಕೊಳ್ಬೋದು. So you can try with that also. Here I am going with R3. ಯಾಕೆ? R2 ಆಲ್ರೆಡಿ ಎಲಿಮೆಂಟ್ 0 ಇದೆ. ನಾನು R3 R4 ಎಲಿಮೆಂಟ್ಸ್ನ ಮಾತ್ರ ಏನು ಮಾಡಬೇಕು? 0 ಮಾಡಬೇಕು. R3 minus 3 times R1 and R4 is R4 minus R1. So what is the equivalent matrix that we get? 1 0 1 1. ಫಸ್ಟ್ ರೋನ ಏನು ಚೇಂಜ್ ಮಾಡಲ್ಲ. ಸೆಕೆಂಡ್ ರೋದಲ್ಲಿ ಆಲ್ರೆಡಿ 0 ಇರೋದ್ರಿಂದ ಅದನ್ನು ಏನು ಚೇಂಜ್ ಮಾಡ್ತಾ ಇಲ್ಲ ನಾವು. 0 1 minus 3 1. Then 3 minus 3 into 1 is 3 minus 3, which is 0. Then 1 minus 3 into 0 is 1. 0 minus 3 into 1 is minus 3. 2 minus 3 into 1. 2 minus 3 is minus 1. The fourth row, that is R4 minus R1. 1 minus 1 is 0. 1 minus 0 is 1. Minus 2 minus 1 is minus 3. Then 0 minus 1 is minus 1. You can see these are two similar rows. You can either perform operation and make one row as 0 or go ahead with whatever the process that we are following. So now we have to convert the elements in this row also to 0. Already ಇಲ್ಲಿ 0 ಇದೆ. So ಈ ಎರಡು ಕಾಲಮ್ನ ಮಾತ್ರ ಮಾಡಬೇಕು. C3 is C3 minus C1 and C4 is C4 minus C1. So the equivalent matrix that we are going to get is 1, 0, 0, 0 and then 0, 1, 1, 1. Look at that. What do we get? 1 minus 1 is 0. Then minus 3 minus 0 is minus 3. Minus 3 minus 0 is minus 3. Minus 3 minus 0 is minus 3. Then 1 minus 1 is 0. Minus 1 minus 0 is minus 1. Sorry, plus 1 here. I am sorry. Here it is 1 minus 0 is 1. Minus 1 minus 0 is minus 1. Minus 1 minus 0 is minus 1. Okay. So you can see that the first row, first column, except the element A11, all the other elements are zeros. Now come to the second row. Already 1 is there. As I told you, we can make one row because you can see that these two are similar rows. We can do that operation, and so that we are avoiding some operations, some extra operations. Okay. So let me say R4 is R4 minus R3. With this operation, what do we get? The equivalent matrix that we get is 1, 0, 0, 0, 0, 0, 0 here, and then 1 minus 3, 1, 1 minus 3 minus 1, because only R4 is being changed. 0 minus 0 is 0, 1 minus 1 is 0, minus 3 plus 3 is 0, and minus 1 plus 1 is 0. This has made our life little simple. Now what we should do? We have second row, second column entry 1. So make these elements below this to 0 and the elements in that row to 0. So let me take the operation. R3 is R3 minus R2. The equivalent matrix is 1, 0, 0, 0, 0, 1 minus 3, 1, then R3, 0 minus 0, 0, 1 minus 1, 0, minus 3 minus of minus 3, minus 3 plus 3 is 0, then minus 1 is minus 2. You can go for making this. This row is already 0, so you just write that. What is the next step that we need to do? We need to see to it that the elements in that row is 0, because we have made these two elements 0. Now we have to see that these elements are zeros. What are the operation? So what are the operations? C3, isn't it? C3 is C3 plus 3C2, and C4 is C4 minus C2. The equivalent matrix is 1, 0, 0, 0, 0, 1, 0, 0. Then 0 plus 3 into 0 is 0. Minus 3 plus 3 into 1 is minus 3 plus 3 is 0. 0 plus 3 into 0 is 0. 0 plus 3 into 0 is 0. Go for the last operation. C4 is C4 minus C2. Sorry, C4 minus C2. 0 minus 0 is 0. 1 minus 1 is 0. Minus 2 minus 0 is minus 2. 0 minus 0 is 0. You can see that there is one 0 row here, which we shall try to shift. Okay. Because we know in normal forms all the 0 rows or 0 columns will be after the unit matrix. Because here still there is one column where you can see one element. Therefore, I just want to interchange these two. How will you do this? You can go for the operation C3 being interchanged with C4. So the equivalent matrix is 1, 0, 0, 0, 0, 1, 0, 0, then 0, 0, minus 2, 0, 0, 0, 0, 0. So I think just this element, if I make it as 1, my job is done. So let us go for the operation. Either R3, RC3, anything you can take up. So that should, to convert minus 2 to 1, that should be giving you the normal form of the matrix. So let us see how we are going to do that. So just one more operation, that last operation that we need to consider is R3 is R3 into minus 1 by 2. So the equivalent matrix that we are going to get is 1, 0, 0, 0, 0, 1, 0, 0. Then third row you have to multiply by minus half. So you have first element 0 into minus half is 0, 0 into minus half is 0, minus 2 into minus half is 1 and 0 into minus half is 0. And last row is as it is 0 already. So we are going to write this. Look at this. Now you have this in the required form. So what is this form? Is it in the normal form? Yes, of course it is in the normal form, because you can see that there is a matrix, this matrix. If you just think this matrix, you can see that this matrix is a unit matrix of order 3 by 3. Therefore, this is in the normal form. This matrix is in the normal form, in one of the normal forms given by IR 0, 0, 0. You can see that there is one 0 column, okay, and there is one 0 row. So that you can write it in this particular form. IR 0, 0, 0, 0. So with what is your R? R is equal to, what is the order of the unit matrix here? R is equal to 3. Therefore, rank of A is, row of A is equal to 3. So this is how you can get the rank of the given matrix by reducing it to normal form. Here is an example for you to practice. The matrix given is of order 4 by 4 and you have to find the rank by reducing it to normal form. So we have done quite a few examples. Hope you all have understood how to reduce the given matrix to normal form and hence find the rank of the matrix. So you can try with this example. After this, we have few multiple choice questions which will help you to know how much you have understood the topic. Here the question is the rank of the matrix A by reducing it to normal form is. That means there is a matrix given here. You can see a matrix is given. You have to reduce it to normal form. So you do it separately in a worksheet and then tick the correct answer. There are 4 choices given. You have to tick the correct answer. The normal form of the matrix A is. So here once again, only the thing is in this example, they have not asked you the rank. They have just asked you to reduce it to normal form. So this matrix is here, reduce it to normal form by how we have done, looking at how we have done the earlier examples and check which one will be the form which you are going to get. There are 4 answers. You have to choose the correct answer. Every m by n matrix of rank R can be reduced to the form. You can see which form you can reduce it to. So this one you will be able to answer if you have understood the definition of normal form of the matrix. The rank of the matrix by reducing to the normal form. So once again there is one more problem here where you have to reduce it to normal form and choose the correct answer by looking at what is the unit matrix you have got in the normal form, because you are supposed to write the rank of the matrix. The other example is again the rank of the matrix by reducing to normal form. So these are few examples for you to practice, which will help you to get familiarized with reducing the given matrix to normal form and getting the rank of the matrix. Again, the reference books, you can go for getting any one of these books, or if you are able to get all these books, it's well and good. You can collect more number of examples and try to solve them. Thank you.